Hello? What is that? Hello, everybody. I apologize for the delay. As you know, I'm going to talk about AMSAT 2, AL109, and it's experiencing some puzzling situations that we're looking at. So I think that it was just proper for Twitch to do the same. And at 5 minutes till, when I hit the go button, Twitch said, no, you can't. So anyway, hopefully I'm there. And I would like to then just go over what there is, what has happened in the last week or so, or generally overall, with the commissioning of AMSAT 102 or AL109 and the situations we've been encountering. Usually I say a lot more and more often about what's going on because, well, usually things work better. So what we wind up with in this case is that there's a lot of things that we don't know. There's some things we do know, and there's a lot of things to work out. So the time to try to put that all in writing is prohibited. I couldn't do that. But I can get on here and talk real fast and tell you a lot of stuff. So that's what I intend to do. Give me one moment, please. I got to check settings since everything went hairy on there. And then I'll kick it off. I'll be back in a second. Oh, okay, I'm back. I was getting some information that there was an echo, and I think I took care of that. So what I had done was that the camera microphone was picking up the sound as well as the intended microphone. That's probably what it was. I shut that off. And I see some chat there, so G0ABI, if you want to just let me know if it's better or not, that's cool. I know there's a bit of a delay before you see what I said, so tell me what you think. Thank you much. Okay, so then I shall proceed. I said I do intend to do an update as well as some Q&A. I've never done an activity or a presentation and Q&A on Twitch before. In other words, it might be difficult to catch all of the questions as they come by in the chat as I'm going through the items here. So I'll try to keep an eye out for it, and maybe if y'all want to, if you're posing a question, just put question in caps or something so I can pick it out better. I'm old, but the chat doesn't seem to get much bigger as far as, and I'm not going to play with it right now. So here we go. The possibilities that we have under investigation. I put together all of the things that we've been working on, not all of the things, I take that back, many of the things, because it's developing day by day. So let's go through with some of that. So we're looking at, one of the things we're looking at is the commands and the apparent lack of effect. The IHU would handle the commands. And in part of that argument, as we discuss it, we have sent several commands since launch, and they were all, well, hey, it started with the ones that are in the in-orbit checklist. So those included safe mode, and inhibit IHU is not what would normally be part of the checklist, but as we went into the contingencies and the anomalies analysis, IHU is one of the first and easiest things to check, I guess, because if you turn it off, you'll know it. And so we tried that. We also had tried transponder mode most recently, up until just a day ago or so. So those are the commands that we have set. None of them appeared to have an effect. So we're trying to determine if IHU is dead or operating or incapacitated. If it's dead from the lack of power, in other words, the battery's low, which is one of the instances that we're looking at, then it could be that, then it would be that it cannot receive any of those commands or process them. And the problem is then, too, that if it's dead, we wouldn't know whether or not it should be working. We can't tell if the commands would even have taken effect because it would be ignoring them. So we're kind of in a position of going, all right, what could we do as far as trying to determine what the IHU might be helpful with? So in looking at what we have, kind of an overall view, the possibilities for the weak signal on the transponder, very weak. The total lack of beacon, although it might be very weak as well, might have been. One of the, kind of like anything you troubleshoot, you start at one end, and the end would be with the receive antenna, the possibility that the receive antenna actually broke off. And I got a little image to go along with this. So in that sense, I got to go look at my notes here. If the receive antenna did break off, that would explain the weak transponder, because the strength of the output of the transponder is related to the strength of the input. So if it can barely hear you, then it is going to repeat a very, very weak signal. And the strong signals that we have been testing, well, obviously it will repeat them at their strength. We have the history that the antenna was broken during testing, and that's what this image shows here. This is a photo I took when it had broken off, and you can see, you won't see my mouse, I guess, but in the green area there, you've got the white thing is an insulated standoff that we wrap the antenna around. But to the left of that, you can see a bit of something soldered on to a sort of L-shaped trace. That is where the antenna attaches. And that little piece there is the part that's soldered to the board. And this piece here is the antenna, the remainder of the antenna that broke. In looking at that, thinking about the fact that it may or may not have broken off, we should still hear the beacon. There's no rationale that because the receive antenna is broken, we can't hear the beacon. The beacon comes on, it's the first thing after antennas deploy, even if they don't deploy, if things go bad. So the beacon's going to kick in, and we should be able to find it. We have looked at it with had some EME stations help us out with it, and a lot of you, and nobody's seen the beacon. So it doesn't really fit that explanation that the receive antenna is the cause of no beacon. And we also have a possibility that then the improved command receiver, the LNA for that, is having a problem, so that if the receive antenna is down or gone, then it is possible that we could have that it can't hear the commands because of that. Especially now, we expect that it would. We expect that it should be able to hear it with the power we're throwing at it. But if the LNA is weak on the command receiver, then that could be a problem with it. And then along the same lines, the ICR may not be working. The path for the signal, the receive signal, goes into the improved command receiver and then on out, if you will, to the passed along to the transponder. So what the transponder is hearing is the same thing that the ICR is capable of hearing. But again, if its LNA is bad or anything to that effect, then it may not be hearing. And then at the other end, one of the things is the possibility that the transmit antenna broke off. The transmit antenna missing would explain for a low signal. And if we could look at telemetry, we'd be able to tell that. There's a lot of signals there or fields there that would tell us, or at least give us clues as to what's going on. So these are all just, we have to go through what could be, and then take that and look at what we know, and maybe even experiment with it a bit to see if we can determine if that's a possibility and what the most likely ones are. The transmit antenna, and I go back to a shot of the pictures included then. Well, this is the receive antenna stowed before I hit the forward button here. You can see that the 2-meter receive antenna, it wraps around a couple of times in order to be stowed. So it does have a lot more stress on it, and it's not an unusual amount of stress, but it is a possibility, something to consider in whether or not it broke off. It may have hung up as well. In one test, I don't know, several satellites ago, shall I say, when we did a test deploy, it started to deploy, but the tip of it here got caught in the wraparound there. So it just kind of came loose, it didn't actually deploy. And onto the transmit antenna, you can see that it being just about 6 inches for UHF, we don't really believe that there's a chance that it was overstressed or broke off because of stress, because it really does have very little stress on it, relatively speaking. That's nitinol we use for the wire for the antennas. It's not shaped or formed, it's just springy, so it works really well. It also, we tested, was capable of staying stowed for a long period of time, relatively speaking, in months. And we needed that to determine if it's going to be able to survive some of the launch weights that we have. The initial material that was tried, which was, I think, copper beryllium type of material just before my time, it wouldn't do that. When it was stowed and then later released, it was like a nice curved antenna. If any of you saw the demo Fox satellite, the engineering demo they call it at the Hamfest and stuff like that, initially had that type of stuff, and you could see how bent the antenna was. So the transmit antenna, not a likely failure at this point. We haven't discarded anything yet. We move on then to, boy, I'm getting a lot of subscribers here, huh? I don't know how to turn that off. Well, everybody deserves to know. Thank you. So next item up here, kind of just marching down a various chain of easier stuff, if you will. Transmitter failure, of course. We have seen this transmitter, the Fox 1E, fail, and that was during ground testing. When it failed, it was very obvious. It still put out a signal, but it was much weaker. but the failure state left it with a bunch of spurs. So you would have the carrier if you were doing CW, and then you have all these little spurs off to the side. So it's not likely that it has failed like that. We also had some problems with it when it was flown on Husky Sat 1. Now, we worked closely with them to develop something for another partner to use, since it wasn't our radio, our satellite, and helped with integration on it. But once we've given it to them and they integrate it, we don't know what's going to happen after that. We know a general idea of the design of their satellite from the web page. You can even see it. But so, we ran into the problem where you could see where the transmit power had gone down when we opened it up for transponder after we got it back from, or after they were done with their mission. So we could see that the power would decline, yet the beacon was always able to come through. So even if the transponder was acting funky or low power, if that's the case, like in here, the beacon was still there. And with EME stations looking for it, we are not seeing a beacon. So we don't believe the transmitter has failed. Do a little tweak here. I'm going to make me bigger. Then when I gesture with my hands and stuff, you can see it. Nah. Oh, right there. Cool. Okay. So now we're getting into what we're pursuing currently. We had been trying some commands to attempt to see if we could get the IHU to respond. The commands were chosen so as not to upset what we have now. In other words, the transponder is working weakly, therefore we have something to be able to determine if it's alive at all. And so the commands we were sending to try to put it into transponder mode via the IHU were intended to wake the IHU up so we could see a beacon if in fact that was what the situation was. And the team worked on some ideas regarding what one of the other possibilities, and that's the DC power. So we have, of course, seen some failures with the DC power previously. Perhaps one of the most notable was the Fox 1 Cliff and the solar safe. And what that wound up being was that there was a short between a couple of the bus leads. And the solar safe is a signal that is held to ground by the RBF pin and the separation switches. Not the separation switches, sorry, just the RBF pin. And so it turns out that when that so if that's pulled low, it cuts off the solar power, which of course means if you got some battery, but then that's going to run down. So that was our experience with that. Gives us background on what we might expect if the power was low because of no solar. Yet the thing keeps operating, so it does not, quite meet up with that point that the problem is the battery's not charging, because I would say, and it's general agreement, that it certainly would have discharged by now since the transmitter's working. There is a scenario, the second line there, where the low voltage explains no beacon. This is a report by Burns Fisher, some of it, WB1FJ, and he does IHU software. He's our software lead. So what we did is we did an experiment with an LTM, which is essentially what's in Fox 1E, because he had thought that the transponder can work at a low voltage than the IHU can. So he did an experiment to explain on that, to try to determine if that's possible. With low voltage, the IHU will shut off before the transponder. In other words, the IHU actually can operate lower than the threshold that is set, but we have it shut off because if it gets below a certain threshold, then the MRAM, the static memory, can get corrupted. And so we don't want it to go there. So if the voltage is lower than whatever that is, I forgot, but you know, it's down in the like 2.8 volt range, I think. If it's lower than that, and the transponder is still working, that could explain the low transmit, the low signal, because it's not got as much power to put it out. And the higher uplink, of course, higher uplink signal will create a greater downlink signal. And I'll talk about that in just a little bit, about how we're looking at that. But that would, in sending a higher power uplink signal, in order to see yourself worth a hoot on the downlink, it should be draining the batteries more. So we're looking at that. So, and we're not certain. It's in determination right now whether the improved command receiver works below the IHU voltage as well. Not known right offhand. If that's true, that it's working below, we can still get through some commands to be able to do some things that don't require, you know, a specific IHU action. In other words, we might be able to wake up the IHU. And we did some testing the other night, and in doing that, by sending a carrier and looking at the strength of it, as well as when we were doing Doppler checks to identify the object, Mark Hammond and N8MH was doing the testing. I was encouraging him on the side there, and he noticed that as the satellite passed through TCA, it was gone. So there were conjecture that if the RX antenna is not there, if you recall from the picture, I guess I can pop that up there again. Not quickly, because I'm still a novice at this twitchy stuff. So if it had broken off right here, like it showed in the first picture, and all we got is a trace and maybe a stub, that's on the plus Y side, plus Y solar panel, I believe. And so as it rotates, as it spins, it could be that, especially if it's a low spin, that side of it spun away from him, however you want to put it, for the last half of the pass. And that's why it couldn't hear his uplink signal, because it's just a little stub pointing off out into space. But we tested last night. Yes, last night. Again, Mark Hammond, and I was cheering him on. And the signal was visible through the entire pass. So we did see fades. And so its spinning hasn't been calculated yet, because the RF fade is hard to determine exactly what the spin rate is, but the fact that it's fading is an indicator of the spin. Yeah. So, but he was able to do the uplink test through the entire pass. So that kind of is the opposite of the thought that maybe the antenna is broken off, or if it is broken off, it didn't point away. Again, all of this is a neat puzzle. I mean, it's just a big puzzle, and we're working with something that we can't touch or see. It is, we know a lot about it. We have, throughout the Foxes, whether or not it's been published in any particular way, it's been among the engineering team that we learn stuff from it, right? So there we go, we're learning. So we know how this may or may not work to an extent. We can experiment with that to an extent, and we can experiment with the satellite, but it's hard to just make a determination that something is or isn't. Worked last night, didn't work tonight. What does that mean? The conditions are all variable. You gotta try to lock that down. So one of the questions that was part of the discussion about the low DC power was, when that fade happened, does it act similarly in sun? And that's what we're working on right now. We're at a point where the pass times, sorry, hang on a sec, there we go. The pass times are getting to be where we're at the border between in sun and not in sun. So what we have is the ability to look at what the signal is like and whether if there's a beacon, but do the same tests as we're doing now with a calibrated signal up, the same conditions as far as LNA and receiver setup, receiver gain, whatever, same antennas and things, same power up, to try to get it as even as we can and see if there is any less power available between, yeah, I've got like allergies like crazy. So if I all of a sudden mute and disappear for a second, it's like you just don't want to hear it. So by looking at it that way, if we can see it coming up in the sun, we send a signal, we look at what we're getting back down from the signal, and then as it passes into eclipse, is there any change? Or does that begin a gradual change? So throughout the eclipse is what we're interested in, and especially at the other end. If we look at all that, then what we're doing is trying to determine whether or not there is any decrease in power or signal strength to indicate that there may be a decrease in power, if power is in fact the problem. So we're going to continue it for several days. It's a slow process because we're poking around. We don't have any, that's how important this beacon telemetry is. It's like, that's why it's the first thing that everybody looks for on their satellite to find out what the health is, what's going on. Even if it's bad, at least you know. So this is totally working in the dark, and that's what makes it kind of cool as well. It's different, you can argue that, it's broke, but at the worst, if we can't get it to do anything, we'll learn a ton. So, as far as AMSAT's goal, it's not in vain. It's part of the exploration and development. Vanderbilt University now, they suffer the most, really, because the beacon is where they would get their data for their experiment. And it's kind of a bummer that, the customer gets really shorted on it. Okay, so the pastimes, blah, 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 and we may come up with some other stuff in the meantime. So you see on the pictures there that I'm just showing that from my QTH, how you can see it's both in sunlight and eclipse, and will pass into darkness as it doesn't pass by my place. More DC power stuff, excuse me. This is just a chunk out of an email, really, as we speculate what might be going on. So looking at the idea that the IHU may not be working, but the transponder or the transmitter is, why doesn't the transponder dip and cut out when a strong signal is sent? In other words, if it's on the threshold, if it's lower than the IHU is going to want to run, it doesn't take much power draw to just push the thing down where the batteries crash and everything will stop till it boots back up. So, or starts back up. So if the voltage drops off and it shuts up because it was drawing too much power, it will pop back up, perhaps not till sunlight, but that's what we're trying to find out. When it pops back up, even if it's still low, the transponder will kick in again. So, why doesn't it cut out? What are the characteristics of being on the edge of insufficient power that we might be able to observe, absent the telemetry telling us what it is? In the FMs, we know that if the bus shuts down, if the power goes too low, it just draws it all down. We know that from the FM, and of course in the flight model testing of AMSAT 2 as well. Now, while draining the battery is not quite the same as the scenario as it may be here, because we don't really have a good idea what it is. Nonetheless, why is it that the transponder can work on, that much power budget, but below what the IHU gets? The thing about that is, if it's truly down there doing that, if it's operating at 2.8, anything less than 3.6 volts, if it is able to operate and the IHU isn't operating, that means it's below, say, 2.8 volts or so, and that's what I refer to as just suicidal territory, because I know from all the testing that we've done with all the Foxes that if you get down to that point, every time you're drawing from the batteries, you're killing them. So I certainly hope we're not in that situation, and my feeling is we're probably not. But then I'm an optimist, so am I fooling myself? I don't know. Excuse me. Well, cat's all left anyway. Okay, so then going on with that, see, this is where we go with this type of stuff. Well, LTM is going to fly on golf, and we're also making versions to share with partners. So something to consider out of this, right off the bat, on account of we're into the golf tee project, the whole idea of the transponder working by itself or headless, no IHU telling it what to do, is because at the end of life, if everything else is kind of dead, well, the transponder works. Just like the FM, the Fox FMs were able to work as an FM repeater with no telemetry or whatever, as well as it's just carrier operated in that sense. Well, the transponder here, it just turns on, and if you want to use it, you can use it. And that's a good design for the end of life. But if it's going to act like that at the beginning of life, in a situation like this, that may not, if it's true that it is what we're talking about, 2.8 or below, that's a bad thing. You don't want to have it go to that operation and be drawing power when the power is so low at the beginning of life, because it really ruins your chances to rescue it. So that's something to take into account as we look at golf. And that's about all for the power. So that's what we're going to do. We're going to continue to do that testing with signals. Nobody use the transponder, please, because everybody who does gets a slice of that power. We want all that power to be there. If it gets used by anybody on any other particular pass, then we don't have as close a comparison as we can get to the similarity between two different nights or deeper into eclipse or whatever. So we got back to the IHU then. One of the things that I put forth the other day is maybe the IHU is confused, because we had sent a bunch of commands back toward the beginning, and perhaps too fast for it to process it, if it's got some kind of impediment, if it's got something impeding it, disabled. So we might have put it into a la-la land, because like computers do that, right? And try and say that to a bunch of software engineers and walk away, though. So that's a possibility. That's something we were also going after with the transponder commands we were doing, is looking at the possibility that if we do a command that doesn't specifically involve IHU, can we get IHU to be unconfused by sending it some commands? So because there's a possibility, came up in the discussion, if you will, that IHU could be in a confused state. It might be locked up, sort of, and if we aren't certain we could command, we can't be certain that we can turn it back off or turn it off and back on, or maybe we did, or maybe we didn't. Maybe we turned it off and it won't go back on. It's hard to say, because we don't know what commands are happening. So going slower is the way to do it. And that's why the progress is slow and deliberate in this. Like I said, we'll do several days on the power. Everything has to be done at a pace where we don't get ourselves into a situation where we kill ourselves. That's no fun if we do. More thoughts about the IHU. And the IHU, of course, is key to generating the beacon. Therefore, a lot of thought going to IHU as well as transmitter. So there's the control lines. There are signals in and out of IHU for like the data for the beacon, for the telemetry and the control of the transponder, and the beacon modes and stuff such like that. So if those lines are impeded, it may be on and it may be sitting there going, dude, I'm sending a beacon. I don't know what your problem is. But it doesn't know that it's not controlling the transponder, or the beacon isn't going anywhere. So that could be a situation that we have to find a way to create a situation where we can go, man, maybe that's it. The beacon modulator is something that is external between the IHU and the transmitter, and it takes, like I said, the data for the beacon from the IHU, creates a driver for it and sends it on to the transmitter. If it failed, it wouldn't be doing that. And we did have events back in early testing engineering model, where the transmitter was getting hosed and we found out that it was because, and I don't recall the exact details now that I'm sitting here telling you, but what essentially what was happening was that when the beacon came on, if the transmitter wasn't on or ready, the beacon would spike a signal to it, and then it would just hose it. So we do know that happened in the past. It was corrected to, as every extent that we could test it, and it stayed that way up until the delivery and integration. So, but nonetheless, it failed before. It could be a candidate. Everything could be a candidate, almost. Everything but the guys who built it. And there are many other possible items. In everything that we do, as we peel through the layers, if you will, and look at the results of what we're doing, what we're trying, what we're testing, it may lead to other stuff. And that's okay. It's more leads. I hate to see a dead end, because then you're like, well, I guess that's it. So other stuff may keep coming out. We'll go after that. And then the standard reminder about the transponder, which I mentioned. I know the desire to explore is there, and it's great. And when we have an opportunity, I certainly want to get people involved. But right now, because of what we're doing, if there's any use of the transponder, while it's over the U.S., in range of the command stations, pardon me, it's going to mess up our measurements. As well as, if it is low power, if we have low battery power, which is what we're looking at right now, if it turns out that it's true, if you're using the transponder, even if you're not in the U.S., especially if it's in eclipse, you could be helping to kill it. It's killing itself. It doesn't need any help, right? I guess that's it for that. So as far as the slides go and the update, I wanted to close the slides out with this mention in an email from our NASA mission manager. The whole integration process, all the teams, Alana 20, there's a group email list, which is actually not like a at Yahoo or something. It's just everybody's address. All of the information about what's going on comes into there. We have a meeting every 2 weeks, and everybody updates and discusses and stuff. One of the cool things about Alana missions is that there's a lot of new people, and there are experienced people. People know, so you have a variety of knowledge out throughout the whole thing. And after launch, with, I don't know, maybe 4 failed satellites, or undiscovered. Some can't find what their object is. Some don't hear anything. We didn't hear anything for a while. And then some are in degraded operation or something. But the point is, in trying to find the objects, we've been on there on the email, which NASA and Tricept and Virgin Orbit have kept going, and let us just carry on with discussion. And that's a really nice way to incorporate input and discussion and ideas with all the people that are in the mission. So all the aspects of what went into this, everybody's CubeSat that was integrated, there is a lot of knowledge there to draw from. So we kick around things, we talk about various things, and we report to NASA and TRICEPT that when we discover, when we hear our first signal, when we get our object chosen, and items like that. So there you go. And I had mentioned to NASA and TRICEPT and in front of everybody, I think, but that it's a really nice opportunity that they gave us to be able to, just keep discussing that without them saying, hey, you're chewing up somebody's resources or something. Most of the time that doesn't happen. They were very pleased that it happens. And this is part of what the mission manager said, which I thought was pretty cool. He said, good luck and have fun with the exploration ahead of you. The journey is supposed to be educational and challenging. Some people seem to forget that. So that's something I mentioned earlier. It's I don't know, it's cool reinforcement to the fact that, okay, this is not what everybody expected, certainly not us, but it's not dead. I mean, you don't spend 3 years on something and then go, oh, well, I guess it doesn't work and walk away, right? So we're all into doing it, and it is exploration. It's space exploration. That's part of what AMSAT does. We build cheap satellites with people volunteering their time in their hobby, doing what they like to do. I mean, if they weren't working on SDR or, power supplies, MPPT, whatever, with the Fox satellites like we were doing, they'd be at home doing it. So we're blessed with all the people that are willing to spend hours, days, weeks, months, years to get a satellite to orbit. And so that's, that it doesn't stop as soon as it gets there unless it does work flawlessly. Then we give it to ops, and there you go. So that's it is fun. It is an upside. It's a confusing one. It's a tricky one, but I mean, gee whiz, it is one of the opportunities that I don't know how to say it, but I guess it's the only way you can get it is to launch something and have it not work, right? Not that we planned that, no. And it's similar to Fox 1 Cliff. Fox 1 Cliff, of course, was a big disappointment because it can't hear CHS, I guess you call it, right? But if you have looked at the telemetry, what it's doing for us is providing invaluable data about what goes on for the Fox satellite design, FM, in orbit, without the thing being hammered by transmitter on all the time and users and blah, blah, blah. In other words, what is the environment like? What are the temperatures like? What are the resets? What's the battery condition? The previous Foxes, they didn't live as long as expected. I guess I can touch on that. But the fact is, Cliff will provide some very good information about what its battery does. Does it, how it declines? Is it comparable to what the others were? The others, I don't know, 3 years or so they lasted, let's say, while the requirements said that it shall be engineered for a minimum of a 5-year lifetime. Well, it was. Unfortunately, at the time that was written, NiCad batteries of the type that we were using, they went out of business in a sense. All the good ones went away. There was a batch of good ones that we had for testing and matching, and they sat around for a while. I mean, everything was out of production. I went to Batteries America, and Everett, he said, oh, heck yeah. And he gave me 5 match sets of the NiCad batteries. These are the Sanyo. I got to look. Anyway, they're really good stuff. But he said they were a smaller capacity. Instead of, I think, 1,600, 1,700 milliamp hours, they were 1,450 or 1,400 milliamp hours. Because he said, the batteries, the cells that you wanted to use have been out of production so long, all of the stock has less capacity than the newer yet smaller capacity cells. So we went with those. But then they were right at the end of production as well. And he said, when I asked him later about some other satellite opportunities, he said, nobody makes any good NICAD cells of the type that we're used to seeing and the type that were flown prior to my being inside AMSAT. You know, he said, there is nothing that I could give you in a NICAD because they're all cheap stuff. So we were fortunate to get the 5 sets we had. We were unfortunate that it sat around so long. We were more unfortunate, too, that the design of the satellite didn't allow for the tending of the cells the way they ought to be. And so that was a lesson learned, right? But it grows out of time. I mean, in 2009, hey, these things were hot and they were just what we needed. 10 years later, well, you know, they're dead. So it's kind of weird. Oh yeah, there's my airplane. I want to see if I can get, nah, I can't. So you can just look at me. I got the screen on back there, but I don't need it anymore. So with that, I'll go over to questions. And I think I talked a little bit longer than I had planned, but hey, you can get a lot more information out that way. I don't know what the camera battery is going to do. They usually last about an hour at this resolution and stuff, so it might kick out. And if we're close to done, yeah, maybe. And if I can pop a new one in to finish, I'll do that. So I'm going to look see if there's any questions. N8 Charlie. Sorry, man, it's like small print. November 8 Charlie November. For those of us capable of receive during daytime passes, is it helpful to record IQ downlink on SDR and send them along for analysis at all? And all the input's helpful. The real thing that right now I can think would be the target would be the beacon, but the beacon's not really there. Now, as far as we can tell, if you listen on the beacon frequency, that can be very useful still. And then if you see a signal, to record it, or as well have FoxTLM running to see if it plucks out any telemetry. So I would say yes, listening is a great help. Listening to the signals that we're going to be putting on the transponder, I don't right offhand see it being of any value because it's such a subjective comparison in the first place that it's, between the two command stations is pretty much it. And the IQ or any type of recording of it is then from your signal strength at your location. So it's not really a value in that sense. But the beacon, God, yeah, anything. So everybody wants to just hone in on that, like if you're not doing anything else or something, or even automatically. And if you do get some beacon, an IQ recording is great. And like I said, also through FoxTLM, or we can play it back through FoxTLM, I guess. But that's what we're looking for. You want to make our day? Show me telemetry. So that would be very much appreciated. Everybody who wants to listen, let us know if you hear anything. And it will be, gee, I don't know how to describe it. Kind of like 2 lines, right? On your trace. So 1200 BPSK. And Peter says, yeah, it's very nice that this stays open. There were other comments in that email that I didn't include because they were more, specific to that, and also other missions that I didn't think I should probably share. But the overall point was that it was really, it was unusual. It's actually a first for me. There was a comment about the last launch mission that was handled by NASA and the total lack of any kind of that. And in the previous Alana that we've done, excuse me. Yeah, you wonder why I am the way I am? You got it. You got to maintain it. So there was exchange. There was exchange during the calls, especially. Something would come up, and if it had to do with like amateur, of course, licensing or things that we had experience with, radios and blah blah blah, I would volunteer to say, hey, let's talk offline, and we'd solve something. So it's all really been good. This one's just the one that's been sustained, I guess you'd say, and it's interesting. It's very cool though, because a lot of people are new, like I said, and having your first CubeSat fail, we and I especially am extremely lucky that the first one worked like a charm, or maybe not so, because like that was a a fake, right? Faked me out. They ain't all like that. But the thing is that some of the others that were on that first mission with us, I mean, these are kids in college, and they spend the same amount of time that we do designing, building, testing, and getting something launched, and then you don't hear a peep. It's like, well, you don't hear it from them again either. And I don't know how to, pat somebody on the back and say they're there, because that's part of the experience. But it's a big hit. It's a big loss personally for everybody who contributed when something's like that, because it's like you don't get a you don't get a do-over. You build it, you put it on your desk, and you can pull it out. If it doesn't work, you go fix it. So the Virgin Orbit and Tricept were credited with providing the support they did. And I will say about Virgin Orbit as well, that I really liked the way they handled everything. They are totally different than what I have experienced before. Our launches before went on ULA and SpaceX, ISRO, I think that covers it. And that's kind of business-like, right? I mean, NASA does the publicity for a lot of stuff, but VO has stepped in and done just a ton of stuff that was for the public, sharing stuff, but also giving us the best experience. Now, we were the first ones ever to be integrated, so maybe it was kind of like a, red carpet treatment or something. I don't know. But I mean, really, the way they laid it out and what they did was really nice. They are very much behind their product, and so I appreciate what they did. I imagine that they'll do it with others as well. Yeah, the Virgin Orbit launch was cool. I don't know if you saw it. We had a feed during the launch that was not a public feed, although they showed PR stuff. And I think it's starting to show up on the web, on their website, and actually YouTube, because it's video. But they interviewed every one of us that got integrated, and individually, the team. And we talked about, I don't know, whatever subject they they tossed at it. A little bit about the satellite, a little bit about being on launch, the CubeSats and stuff like that. So that produced in those videos. If you want to go look for them, I'm sure they're on YouTube, because I saw 2 of them, and that there's probably more coming then based on the dates. And I think there was 4 of them total in the during the launch program. So those are good to watch to see what's up with some everybody on the mission, really, and how it all comes together and what they're doing. It's quite a deal. It's quite a deal. And the support while RadFXSat 2 went up there and is not behaving like it should, hey, that's good too. So I hope you understand what I was telling you. There's a lot of stuff going on, and it like I said, it's hard to write about or do some kind of update every week, because it's a lot of thought, a lot of different things that are just trying to be developed and things. I don't have a good answer for anything yet. That's the way it goes. Any other questions? Come on, man. This is it. Or can I think of something else to add? How about this? There. RadFXSat 2, AO109, is a first with a transponder in a CubeSat for AMSAT. It didn't, the RadFXSat 2, the Fox 1E, the 5th Fox, didn't really exist in initial plans. 4 of them were to be built. We had stocked up stuff for 4 of them, all the FM ones. Turns out we had hardware left, that some of the hardware that's, you know, you don't just go buy for the space frame and things like that. And early on, really, it was put forth by users, some users, you know, and ops. Somebody named, I don't know, some guy in Florida, right, was pushing for a linear transponder. And so we determined that, okay, we got the hardware, you know, the hard parts, mechanical parts to build one. And John Klingelhoefer was all gung-ho about doing a transponder, and others joined in on that. And so we went for it. That was, I really do think it was like 2016, not too long after the launch of Fox 1. So the idea came together then, and all the stuff started coming together then. And if you think back, if you were here then, you know, in the satellites when Fox 1A launched, and we were going to do 3 more FM Foxes, it was like, well, a transponder makes perfect sense to go ahead and throw one of those up there too, because we're just going to be having a whole bunch of FM Foxes in the air. But launches don't happen that way always, especially if you're hitching a ride. So it did turn out that, what are we, like, from 16 anyway, 4.5 years later, before Fox 1E was ever launched. And now, especially because the others had the problem, everybody's going, hey, we want an FM, you know, so it's like, oh, whatever. We did it for the experience. We did it for the exploration, the transponder being new and all that kind of stuff. We did a improved command receiver, which was going to be needed for better and more commands to be able to handle to the satellite, different frequency, split beacon. And there's all sorts of advances and thoughts that went into it that then carried into LTM and into, Golf T. So that's the way things progress. And the design and the construction and the learning and everything, all the way to space, is a positive experience for engineering. We're not a corporation that just sits here and cranks out satellites that run perfectly like clockwork, unless we start hiring a bunch of people and paying them. So it's hams doing ham stuff, right? Got a couple more chats here. Let's see. Yeah, on the Peter, the live stream and hiding the live stream, if you will. I'm trying to think about how to say. Everybody knows that Virgin Orbit's first launch demo didn't launch. And the way that the Alana contract was, Alana 20 was going to fly on their second launch, which, even now that it turned out to be their first, again, launch demo, their first time at trying to at flying the rocket, there was, they put a lot of work into it. I'll say that. I know I can say that they put a lot of work, because, when something fails, especially a rocket, and you're a company, they had the kind of process that is what is needed to solve that. I think I mentioned somewhere, I don't know if it was in writing or what, that the process we're in with RadFXSat 2 AO109 is slow, and it's deliberate, because if we do something wrong, we may hose it, right? Well, it's the same kind of thing, except they got like big buck corporations and a lot of contracted people and stuff like that to be able to give even like the top level of that kind of stuff. So and they pushed it back when they had to. So that really, you're on that edge of going, well, God, I hope this demo works. And also going, well, you know what? It might work better than any of the others. Who knows? So it was a little bit of an interesting ride on that. But their caution as far as making it public, well, for one thing, there's not a lot to see. I think you can see now the videos of the drop and the launch and stuff like that, the rocket taking off. I don't know if you get to see some of the stuff we saw with our payloads and things, but pretty much once it's up to orbit, you're not seeing anything at all. It's just telemetry from ground stations. So all we knew was that the deploy signals were sent, and that the whatever the burn wires or the seals on the lids of the dispensers had opened, so everybody was deployed, and no pictures or anything, and there you go. So it wasn't a lot to see, but they had a lot riding on it. They probably don't want public trying to second guess or whatever, especially the press. Nothing personal, but I mean, shoot, I was interviewed at a field day once, and I probably said about 10 sentences, and when the newspaper came out, it was not what I said. So, the press tends to get carried away with some things, and I can see that. I mean, look at what happens with us. You say something, it gets twisted, and then you got that to deal with, as well as trying to make your rocket work. So I think they'll keep going, and I think that they will be part of, I know that they'll be one of the companies that NASA turns to for Alana and whatever type of launches that they do, because the whole venture class launch services, VCLS, that's what this was part of, a NASA program called VCLS. And the idea, of course, obviously, is to help and get commercial organizations with new ideas, help them get started up, get firmed up, and be able to take stuff to space, because that's what NASA does. I mean, they don't just launch stuff. They're like the arm of the government, and they give back with the educational and all that, just like we do at AMSAT. Did many of the other satellites that were on the same launch have issues? If they did, is there anything to be learned there? I know of at least 3 others, because I've been talking to them email. I think the number was bigger than that. Well, there's 4, obviously, if you count us. There were 11 of us, I think. So 4 out of 11, maybe 5 out of 11, that's like dang near pushing 50%, huh? Now, I'd have to look back and see what we discussed or what was said, and then maybe filter that as well to be able to talk about what issues there were. I can say that, especially with the ones I've been talking with the most, which is the PICS group, BYU. Now those are the ones that were 1U, I think, or 1.5, I forget. But anyway, their whole point was to take pictures right after they were deployed. And then what else was there? It's I can't remember. Well, QPACE is a Florida venture. In any case, there has been some, there have been lessons learned just from that discussion. I can't say that I know what their experience is, how many times they may have had a launch or anything of those 2 that I'm recalling right now. But, well, I think it'd be fair to share that the PICS group said that one of the lessons learned is, because I said, hey, we got hams everywhere. Maybe they can listen. My video died, didn't it? I hate that. Hang on. I can keep talking, or if you can wait a second, we can maybe just... It did that the other day, and it was not the camera. It was just Streamlabs deciding that I'm tired of watching that stream or something, Hello. Yeah, well. All right, give me a sec. I hate that. Okay, let me finish what I was talking about then, and you can look at my airplane. PICS, yes, it was PICS. PICS, and I offered. I said, hey, we got hams everywhere. Maybe I can share it, and some people will help you look. Well, the frequencies they're using is in the 900 megahertz band, and so I did tell them that, well, we don't have necessarily a lot of people with equipment for that band, because if you're a satellite enthusiast, you're typically going for the 70 centimeters or 2 meters or something like that and above. So one of the things they came out with a lesson learned, and I like the way they put it, is like, don't use the 900 megahertz ISM band, or if you do, you're going to need a lot of power. I thought that was kind of cool. So their lesson was, well, that was a good idea in general, but there's so much other crap there they can't even see themselves once they found themselves, sort of. So there you go. Yeah, the camera battery died. Well, look, if y'all are good for sticking around, just, I don't know, a few more minutes or whatever, I'll swap the battery out. And I guess if you want to, chat a message, I can't figure out why the heck. Let me try something real quick. Sorry, I can't walk and chew gum nor think and talk at the same time. So you can mull that over. I'll put up the good old AMSAT logo there. How's that? That frozen screen there looks kind of like a good... Nah, I don't look good in any photos. There's only one. Only one I've ever found, and it's like 2015 on the NASA panel for Fox 1A. Somebody took a good picture of me, and it's like, God, all right, I'm downloading that. Be right back in the battery. So yeah, if you see like a profile or publicity photo or something, and I'm looking really good and young, that was it. Although I haven't aged, you can't even tell. It's been 6-7 years that I've been trying to get everything launched. Okay, popping out the battery, gonna go with a new one here. Not as fast as I am with certain weapons, but let's see what happens. I really appreciate everybody being here. I think this is a good time, good opportunity to be able to share questions. See, quit it, not you. Well, I suppose I could play a game. That's what everybody else on Twitch does, right? There. Let's see if that does any good. Should have seen the fun I had before the stupid stream started. 5 minutes till, and I can't sign on Twitch, and the audio feed isn't working, and my. I'm still stuck. It's like, what the heck? Okay, so what? We'll carry on. Throw up a good picture or something. Yeah, SAT passes instead of games. Well, I am working SAT passes these days, but they're all transmitting commands or a carrier. So that might even be boring in itself, right? This is, a ham, y'all hams probably, but so like what do hams do when something quits working like that? You're going to sit here and think, figure it out, by God, until the day is done. I don't know why it did it. It did it once before. Try this. Oh, I did it. See, that's what hams do, right? Here I come. Ta-da! Boy, but that was scary. So, yeah, well, here's the deal that I don't know I don't know if many people, if anybody really knows, all of us engineering, I mean, you know, them other guys, they don't do much, right? But engineering, we work tons of hours a day. It takes a lot of work to get these things in space and working. You know, the theory is you've got 100 volunteers and everybody only has to work a tenth of the time. The reality is, and this is not any different than any ham radio organization I've ever seen, you get about 10% of the people that actually do work. Everybody else is either ideas or, I don't know, ideas. I've seen, I'm just being honest here, I've seen projects that we've done in AMSAT. And you got a lot of people that have ideas, and that's great. You put the ideas together. I mean, that's part of the design and stuff. But then you walk away and you leave about 10 guys who were willing to do the work too. And so that's why things go kind of slowly. That's why we work long hours. And adding volunteers is problematic because of that. I mean, you know, this is a hobby, really. If you rank it, the time that you're going to devote to doing a satellite, it's a ham radio hobby, is going to be way below, you know, your church, your wife, your family, and all that kind of stuff, right? So putting in many hours at all is difficult and variable, unless you're crazy. So that's why I drink this stuff, so I can put in those days, right? But the reality is, so we get people that volunteer with all good intentions, and when you get inside, I guess you'd say, and you start seeing all the work or what you need to commit, even if it's like you say, I'm going to do 5 hours a week, you need to do 5 hours a week. You cannot walk away from that. I mean, you can, but you're hurting everybody else if you're doing it. You know, if you just walk away and don't say anything, I mean, here's my deal. If you cannot do what I'm asking, you say, I want to volunteer. And I say, well, can you spend like 5 hours a week doing this? Just say no. I mean, I like that. I want to know. That's all. Facts. Hey, I can't do it. Okay. Thank you for volunteering. Maybe there's something else that'll come along. If you have to quit volunteering because, you know, family, whatever the heck, death, yeah, it's hard to notify about that. But if you have to quit, just say so. Everybody understands that. We're no different, in that sense than like your ham radio club. You know, you guys gonna do like field day and you can't make it. Okay, that's cool. Everybody understands. And so that's where that is. The thing about then becomes yeah, you don't have all the people so that you can just have all that continuity going all the time. You are faced with many, I mean, these things take years no matter what. You can talk about, oh, well, we should be able to build a CubeSat in like half a year, even a year. And well, you should be able to, but there's not enough people. And then that's the problem. So Fox 1s, when we did Fox 1A, then we go, okay, the order next was C, D, B, just because of the way the launch is laid out. And so what you wind up with is that you'd think, well, okay, so Fox 1A was done. Fox 1C, specifically, especially, is easy because it's just the flight spares from Fox 1A in a lot of cases. And but it included the Virginia Tech camera. And you think, oh yeah, you should be able to do that in a year. Everything's the same. Put the Virginia Tech camera on top. There, you're ready to go. No, it doesn't work that way. And every one of these is complicated. Every one of these has something different. That I mean, totally different. You can't even anticipate sometimes from the previous ones. And so it takes a lot of time to work on that. It takes a lot of time to make it work well. And fortunately, you have that time typically with the launches. But that means that you have to have people that are going to be around for 2, 3, whatever years. And if you don't have that full deck of volunteers who understand where you're at any particular time. That's a big part of it. You know, if you come in halfway through, you got zero idea of what went on before that, which includes a lot of hiccups and changes and, you know, lessons learned and stuff like that. So, yeah, there. So that, I mean, that it can change things a bit. You might have a little relearning cycle or time to catch on and stuff like that. And so it's hard to have that continuity. And with like the 10 of us, I say, which I don't really know the number, but that have stuck around, that's the continuity right there. That's what keeps it going. And we need to have volunteers that are willing to do that. We need to have volunteers that are willing to work 10 hours a day that can do all these various things. And that's really just difficult to find. And I don't blame anybody who doesn't want to do it that way. So there you go. We got deadlines, and the delivery date for RADFXSAT 2 was, I mean the hands off, sorry. The completion date was, I think it was June of 2018, give or take a month, because the launch was to be about 3 months later, typically. Of course, the launch slipped and slipped and slipped, but we had RADFXSAT 2 done for June of 2018. That's one of the things that we do. We do it well. We go with exactly what the mission is, and that's something that makes us very appreciated, I guess you'd say, respected in doing like these Alana launches or even the spaceflight ones that we have. But I mean, you saw the stuff that I put up there about things that, you know, as we're trying to troubleshoot what's going on right now, things that we saw happen in testing or design or previously. When we put the wrap on it, and this is true of any satellite, it's never done, right? You want to just keep going forever. So we're good at just in time. We will have a good working satellite, and the 3 out of 5, I guess. I don't count the ones that the batteries quit in 3 years or whatever. That's not a failure. I mean, the dang thing, it was complete success. All 3 of them. They served their missions. Even Fox 1 Cliff, like I said, I mean, there's science there. Okay, transpond, you can't work the repeater. Sorry. But we still get science from it. So yeah, to be able to carry on for another 2 years to what theoretically would be the completion date based on the real launch, you could have done a lot of tweaking. You could have made things different. You could have learned things, made the transponder better, or whatever the heck isn't working. On the other hand, then you've soaked all of your engineering, 10 guys, into doing that for 2 more years. When RADFXSAT 2 is actually a bonus Fox experiment. It is there solely because, and the board of directors approved it as, look, we got leftover parts. We want to try a transponder. What do you say? Okay, we're on. And so, it is what it is. You don't want to keep everybody working on that forever when you're going to take that very transponder idea, build upon it, make it better, LTM and such, fly it on golf, and stuff like that. There's no point in making all that resource stick around doing Foxes. Back in the day, there was an idea that actually it was like in the strategy meetings that the BOD had back in 2017, I think. We should just keep building Foxes because, we had a lot of people that wanted to fly. We had a lot of partners who wanted to fly experiments and such like that. And it was very popular. Cool. We had the situation, though, in order to do that, we'd have to redesign the power supply because the batteries. We'd have to go with something else. So the power supply has to get redesigned. And the, I can't remember exactly, transmitter or receiver or maybe both, had parts that had gone defunct and needed to be redesigned. So it would have taken a rebuild of the Foxes to continue the Foxes. And once again, you're soaking all those resources into that when you could go on with something else. And there's other people launching satellites. So for the resources that we have, it's one thing at a time. And that's why, in my opinion, we should move on. We moved on to Golf T, the golf project. That all came out of two things. One, us sitting around at Fox environmental tests, us being about 4 of us maybe, but the leads of the various systems and stuff. When, sitting around talking about what should we do next. And so the idea of the development of golf, the staged development, if you will, came from that largely. Eric Skoog, K1TVV, our systems engineer, back in, good Lord, 2015 or 14, when I put out the Design the Next AMSAT Satellite, submitted a nice idea, design, and a lot of that is incorporated into what's going on with it. Same thing, and it's really what we were talking about in the conversations primarily. Then you throw in AMSAT. AMSAT initially we put their efforts toward the communication system needed for the CubeSat Quest Challenge $100 satellite partnership with Ragnarok to go lunar. And that was a good, then the deal on that was that we provide the communications, which included, a lot of stuff like ranging and things. But for the mission was that they were going to go orbit the moon and send back data for X amount of days. I forget exactly what the goals were, and see who could send back the most data. And when they were done in a short time, then they just gave it to us. So we'd have a lunar Oscar satellite transponder, 5 and 10 gigahertz. So, that's a good undertaking. But they did not make the final cut. The engineers went to work on something else, and not too long after, we have these ideas for the RTIHU, SDR was same thing that was developing along with the CQC. What else? Other good stuff. Sorry. So you got all these ideas that come from AMSAT. The engineers came from AMSAT too, and we have a lot of new engineers that are working on golf. We have a new generation of younger, which is really cool. So we got some young people there, and that is cool because they have a big problem with time, but they also have a lot of ideas and enthusiasm that is what's needed. It's got to be fun, it's got to be interesting, and it's got to be something that satisfies every one of the engineers that's working on it, or it won't work. They're not slaves. You're not going to make them do anything. Walk in and say, hey, go build this today, will you? Nope, that ain't going to fly. Literally. So that's what engineering is about. That's where it is. That's why we are what we are, why we do what we do. And we have done great things. I think we can continue to do great things, whether or not anybody agrees that I am capable of doing it. I've got crazy water. I can do anything. So, if there was a point to be made there, I forgot. Can you believe that? Yeah, whatever. That's the way these things work, and that's what we're bringing up next. So I guess I can do a golf update later. The RADFXSAT thing is, Vanderbilt University is not devastated that it didn't work. One of their earlier comments was, "I'm just glad it made it to orbit," because that's a major step in the whole thing. Is getting from the table to the orbit, really. That's a hell of a ride on any rocket, and they may fail and not get you to orbit. You may fail when you get to orbit. So, there's a lot of steps that go along the way that they realize, because they've been partnering with us, that, okay, it's not really quite working right, but by golly, we got it there. So we know you're going to work on it, try to get it to work, blah, blah, blah. And by the way, we'll fly on another one with you. So that's good stuff. That's the way it works. And it works well. AMSAT has put up a lot of satellites in the history, 50 years, And if you throw in the ones before that, and it's pretty amazing. It really is that hams sit around, engineers, and they come up with an idea and they put stuff together and they dedicate all that time to do it. So I'm very proud to lead those people. And I lead by, hey, this is something, I don't know if anybody knows, but I mean, at the railroad with the QA team and development team that I was in charge of, and as well as what we do here in engineering, is a lot like I'm just a peer. I'm part of the group, you know. I will make decisions that have, you know, when they come to it, that have to be made that are good or bad. Well, I mean, you know, whether anybody agrees with it or not, you got to come to that point where you say, no, sorry, this is what we have to do, and that's what I get paid to do. And so, right or wrong, I'll defend it. Which is why I say that, you know, if this thing failed, if you call Fox One Cliff failed, well, that's my fault because I let that go there. And but you also, I mean, I don't claim to know and I don't impose anything about, you know, any specific engineering type of thing, like, oh, you got to do this like that, and I'll do this like that, and it's all up to what they want to create, and they know more about what they want to create. And you take that, and I mean, I've learned a lot. I know a lot about missions, and I do a decent job at leading the team to achieve what we need to achieve. So that's the way that works out. It isn't a production line, like I said. What we have flown is, Fox-wise, is what the engineers can do. So why doesn't it do this? Why don't we do that? Well, we got to have the people that want to do it. Like I said, you're not going to just pull somebody in and say, hey, I want to volunteer, and go, oh, okay, go build a Fox. You could do that, but I mean, you know what I mean. If it's not what they wanted to do, it's not going to happen. So that's why, that's why if you don't like golf, you can blame them. Nope. Blame me because I'm the one who went along with what they wanted to do. So there you go. That's a monologue, wasn't it? What else do you want to know? Need to check something real quick. If I can find it. Sorry. Okay. Well, I don't see any more chat. I don't even really know how many people. I got 21 people here. Somebody's got to have a question or something. A statement about any of the Foxes? About RADFXSAT 2? AO109, I'll get used to saying that. Oh, you know, I don't... Did I say that doing this, the video, the Twitch video is a hobby? See, that's where I was going. With all the work that we do, and there are some of you, if not many of you on here, who have heard me speak a little bit unfavorably about all the work I do, what I wish I could do instead sometimes. But the video, doing this and doing the even the presentation and answering questions, see, video is one of my other hobbies. So this is cool. I mean, I'm learning stuff doing this, lighting and camera, and if you hadn't guessed it, green screen back there. As well as music. Music is cool. So like the song that was playing while I tried to figure out how to make the damn video work was written by a close friend, I say, right? But that, you know, that's something that I like to do. So those two hobbies make this not AMSAT work, really, just fun, more fun. This is a different hobby, so that's kind of weird, though. One of my hobbies is talking about one of my other hobbies. Okay. I guess we've been at this hour and a half. Well, maybe the first 10 minutes of it was just the logo, but if anybody else got anything to say, that's cool. And if you don't, I don't know if you can leave a note to Twitch after it goes offline, but let me know if you think this is a good idea. Actually, if everybody signed up to follow, then I'll derive from that the fact that you're interested in seeing when the next one pops up. And so, you know what? Might be a good idea for how to, say in another week, do another update on AO 109. I don't know if there'll be a lot to update, but hey, come in and do the update. Like I said, I can say a lot more faster than I can type it. And then also take some questions. I think it's a good way to interact with the people that are also in this hobby, enjoying what we do, because we do what we do for fun. And then if you see, my paycheck, I like to say, is when, especially when a kid, a young person, but basically anybody says that, or when they've made their first contact and they make that statement, I don't know, Facebook or whatever, and I see that's like, dudes, I made a contact, I think one of the coolest ones, I died again, didn't I? God, Lord. All right, I want to finish this story and then I'll butt out. That's a hell of a pose, isn't it? I think I'll leave that there. Where was I? Oh yeah. So regarding that, that's what makes me go, yeah, see, this is all worthwhile, is when anybody appreciates it, whether or not, but the new people, it reminds all of us probably of the enthusiasm and the coolness of doing a satellite contact, which it really is. I think it was Fox 1A, AO85. Some of you may know, I guess the Lee children, God, I can't think of her name. Hope. She was, I guess her father made a video of it and she did a contact, and I think she might have talked to Clayton. Clayton, what's his name? Clayton Coleman, W5PFG, former president and all around good guy. So he, in the video, he asked Hope, and she said that, I talked to a guy in Texas. That's far away. And that reminds me of my first novice contact, on ham radio. It's like, dude, I talked 2 states away. That's DX. Because it is, so that's the hook, though, really, that the kid is interested, that gets everybody interested. Kids is anybody 65 and under, that brings them interest and a spark to do something new. And that's part of the educational outreach, I believe, for AMSAT, is that we provide these opportunities for people to learn and want to learn more about space and get involved in future space stuff and what have you. So there you go. I appreciate everybody dropping by. I just noticed some text here, sorry. Yeah, there will be a recording. It should be available after, I don't know how long, but pretty quickly after I stop streaming. So you can come back to the page and it'll feature it right up if I'm not live. AO85 TLE, okay, let's see, NASA Bear, and there we go. And oh yeah, by the way, AO109 has officially claimed that object C, I think 47311, I forget the number. So we are in the catalog as AO109 now. And that the elements there should be good. Okay. Well, since you're looking at some weird picture of me, and I'm about out of things to say, 7-3, everybody. I really appreciate it, and I'd look forward to, doing it again next week or something like that. Take more questions and share more of the fun. So have a nice day. Have a good evening. And if you're over across the pond there, yeah, it's getting kind of late, isn't it? Good night. 7-3.